An important feature in kinematics is the signs of displacement, velocity, and acceleration. We need to know what they mean individually, and we need to know what they mean when we combine them in particular ways. So starting with displacement, and each of these tables is in terms of p. So p is the particle or the point, whatever we're referring to, the object that's moving. When the displacement is equal to 0, the particle is at the origin. Notice that it's the physical origin, not necessarily the point that the object is starting at when time starts. So the object might actually start somewhere to the right of the origin, for example over at 2, and it starts here when t equals 0, but this is when s of t equals 0, the origin itself. And we'll do a couple of examples that will make that a bit clearer. If the displacement is greater than 0, so positive, then the object is located to the right of the origin. If the displacement is negative, it's located to the left. With the velocity, if the velocity is equal to 0, then the particle is instantaneously at rest. Now, this can occur in two different ways. Firstly, the particle might actually be stationary, as in it's not moving, it wasn't moving, and it isn't going to move. It's just stopped where it is. Or it could mean it's changing direction. So for example, if the velocity is positive, then that means the particle is moving towards the right. So that's v of t greater than 0. If the velocity is negative, that means that the particle is moving to the left. And in between here, the particle has to change direction. And it doesn't actually swing around like that. That's the way that we draw it. What happens is it travels forwards in one direction, then instantaneously travels back in the other direction. So between this change in sign of the velocity, there must be this point where the velocity is instantaneously equal to 0. So that means for an infinitesimal point in time, the particle is at 0 because it's gone from a positive velocity to a negative velocity. And yes, positive velocity, the particle is moving to the right. Negative velocity, the particle is moving to the left. So with the acceleration, if we've got a positive acceleration, then the velocity is increasing. If we've got a negative acceleration, then the velocity is decreasing. So this is what we would colloquially known as accelerating and decelerating. If the acceleration is 0, then the velocity is not changing. So the velocity is either at a maximum, a minimum, or is just a constant. All right, so kinematics questions often specify certain conditions which refer to the zeros. And remember that the 0 of s of t, for example, is when we let s of t equal 0 and solve for t. Or we let v of t equal 0 and solve for t. Or we let a of t equal 0 and solve for t. The first one, however, is this idea of initial conditions. So if you're asked for initial conditions, what that means is we want to know what's happening when t equals 0, right at the very beginning of this particle's movement. If we want to know when the object is at the origin, then we set s of t equal to 0 and solve for t, and that will tell us when the displacement is 0 and the object is at the origin. If it's stationary or reversing direction, or when there's a maximum or a minimum displacement, then we let our velocity equal 0 and solve for t. And if we're looking for a constant velocity or a maximum or a minimum velocity, then we let a of t equal 0 and solve for t. We've discussed this up here, that when a particle reverses direction, its velocity must change, and that corresponds to a local maximum or a local minimum distance from the origin. So we start here at the origin, for example, we go out and back, then this is a local maximum distance from the origin. If we change direction again, then this is going to be a local minimum distance. So not necessarily the maximum or the minimum, overall, just a local maximum or a minimum. All right, we've talked about the idea of velocity being a vector quantity because it has both magnitude and direction. And if you remind yourself up here, if the velocity is positive, the particle is moving to the right. If it's negative, it's moving to the left of its current position. Speed, on the other hand, is a scalar quantity, which means it's only got magnitude. It has no reference to direction at all. So what we end up with is, for example, if the velocity of an object is minus 10 meters per second, then the speed is simply 10 meters per second. So that's easy enough. We just take the sign off the velocity to get the speed. If we're wanting to find out whether an object's speed is increasing or decreasing, then we need to do a test. So if velocity and acceleration are the same, and that means they're both positive or both negative, so the signs are the same, then the speed is increasing. If the velocity and the acceleration are opposites, then the speed of the particle is decreasing. It's probably easier to look at that as a diagram. So here we've got a dinosaur running on the left. So the velocity here, he's running towards the right, so the velocity is greater than 0. The other little, what is that, a fox, is pulling forward on him, so the acceleration is also positive, and so this dinosaur's speed is increasing. So think about running along as fast as you can, and then somebody pulls on a rope to the front of you, you're going to go even faster, even faster, even faster. So your speed is going to increase. In this second diagram, however, we've got the running dinosaur's velocity is greater than 0 because he's running to the right, but the acceleration is less than 0 because the other fox thing is pulling in the other direction. He's pulling to the left, and because we've got these opposing signs, we can see that the running dinosaur is going to decrease speed. Think about it. If you're running forwards and somebody is pulling on a rope backwards, you are eventually going to slow down until you end up stopping momentarily and then actually being pulled backwards. So if the signs of velocity and acceleration match, then the speed is going to increase. If the signs of velocity and acceleration don't match, then the speed will decrease. You can also think about the situation where the dinosaur, for example, is running backwards, then the velocity is going to be negative. If you're pulling backwards on someone running backwards, then their speed is going to increase, and it's going to increase in the backwards direction. All right, please have a look at the investigation 2, displacement, velocity, and acceleration on page 415. And then in the next video, we'll have a look at example 10.